Hello student, welcome to the petrochemical class again. Today we will study about the properties and specification of petroleum product. So you can see on the left side we have properties and on the right side we have their importance. So you can see the first is cetane number. This is important to measure the ignitability or ignition quality or reduce the knock and smoke. And then we have cetane index or aromatic limit. This is important the aromatic content of the fuel to prevent advertised emission impact or reduce the knock and smoke. Then we have volatility. This is important for deposits, wear exhausts and smoke. Then we have viscosity, that is injector wear or spray pattern, pump wear, filter damage. So to uh, for these problems we are using the uh, viscosity. Then we have the sulfur content. This is another property of the petroleum product. This is to protect the emission control equipment. And then we have low temperature operability, flow properties, filter plugging. Then we have water and sediment content, filter plugging, injector, increase corrosion. Then we have lubricity, injector and pump wear. Ash content is important to inject and fuel pump wear, piston and ring wear, engine deposits. Then we have corrosion, that is to protect copper, brass, bronze, fuel system and parts. Then we have flash point. This is important for safety during fuel handling and storage. Then we have carbon residue, fuel system deposit and combustion chamber deposits. The property of the petroleum. So these are the properties of the petroleum: aniline point, flash point, fire point, smoke point, cloud point, pour point. Then we have freezing point, viscosity, vapor pressure, API, acid value number, octane number, calorific value, specific gravity, emulsion. So what is aniline point? You can see the first we will come to know about the aniline point. The definition of aniline point is written here. Aniline point for a hydrocarbon or petroleum is a fraction that is defined as a minimum temperature at which equal volume of the liquid hydrocarbon and aniline are miscible. So that means equal volume we will take of aniline and equal volume we will take of hydrocarbon, and we will mix it and we will note down the temperature at which they are miscible. So aniline point is used to measure the aromatic content of the lubricating oil, and aniline point and aromatic content have inverse relation. So used to find out the following terms. The aromatic content, the aniline point is used to find out the aromatic content, diesel index and cetane number. Diesel index tells about the ignition quality of a oil, and cetane number will tell you about the combustion quality of oil. So how do we do this test? It is explained over here. So determination of aniline point. First you take the aniline and sample of oil. Say for example diesel, or you can take the sample as a petrol or other any other petroleum product. So aniline plus sample. You will take equal volume and you will heat in a beaker on the bathtub. So aniline sample and the oil sample is heated in a bath, and then formation of homogeneous mixture. Then it is cooled and cloudiness. The temperature at which the separation of two phases aniline plus oil take place is the aniline point. So you note down the temperature at which both the phases are separated. So that point, that temperature is called the aniline point. Now diesel index formula, the diesel index equals to the aniline point in degree Fahrenheit into API gravity of the petroleum product divided by 100. So this is the formula for diesel index. Then cetane number equals to diesel index minus 3. Now the flash point, it is the minimum temperature at which an oil gives out sufficient vapor to form inflammable mixture with air, catches fire moderately and flashes when the flame is applied. So you can see this is a Penske Martin apparatus. Into this we uh, test the flash point of any fuel. Here we have a cup. We fill this cup with the fuel sample and we heat it with a heater, and then vapor of the fuel is coming out, and when the flash will appear, so you will note down this temperature from the this thermometer. So this point is called the flash point. Next, the fire point. Again, it is the minimum temperature at which the lubricant vapor burn constantly for 5 seconds when tiny flame brought near. So into this case, the vapor is burning for 5 seconds and that temperature is noted down. So this temperature is called the fire point. Why the flash point? And gives us some idea, that is first, nature of boiling point diagram of the system, and amount of low boiling fraction present in the liquid fuel, and then we have explosion hazardous, then we have volatility of liquid fuels, flash point of different liquid fuels. You can see in this table we have mentioned the uh, different flash point of crude oil, kerosene, lube oil, gasoline, diesel, fuel oil. So this is the flash point that is measured using the Pensky-Martin apparatus. Now the important point is flash point equal to fire point plus 5 to 400 degrees centigrade, and if flash point is less than 140 degree Fahrenheit, this is called the flammable liquid, and if the flash point is greater than 140 degree Fahrenheit, it is called the combustible liquid. So in more cases, fire point is 5 to 40 degrees centigrade is higher than the flash point. That means the fire point is higher than the flash point, and the fuel with flash point higher than 66 degrees centigrade are regarded as a safe for storage and transportation. Next, we will come to know about the smoke point. Smoke point, as you can see, the name suggests smoke point. So without any smoke, a flame height is measured into this. So you can see the definition. It is the maximum height of a flame in millimeter or mm without smoke formation when kerosene oil is burned in a standard lamp under closely controlled conditions. So this is the apparatus into which we are using the kerosene oil fuel, and it is heated, and then if, a flame is uh, burning, and this flame height is measured when it is uh, glowing without any smoke. So smoke, why smoke produce? This we will come to know due to the following reasons we have the production of smoke. So smoke is always present due to the aromatic hydrocarbon. When the aromatic hydrocarbon present in the fuel, then there will be smoke. So paraffins are desirable in kerosene because they are the component of the crude oil, and it has got highest smoke point when, whereas aromatics are undesired as it has got lowest smoke point. So in the kerosene we have the highest amount of uh, aromatics. So that's why the kerosene fuel is taken to measure the smoke point. So standard smoke point of kerosene is 20 to 30 millimeter, and aromatics are hence removed from the kerosene to improve the smoke point. So for all the fuels, it is necessary to improve the smoke point so that should be less production of smoke. Now we have cloud point and power point. So what is cloud point? Cloud point of a diesel fuel is temperature at which the amount of precipitated wax crystal become large enough to make the fuel appear cloudy or hazy. Or pour point is the temperature at which the oil just caused to flow is called the pour point. That means whenever the temperature of the fuel goes down, so it start freezing, and a wax like uh, cloud will appear on the in the fuel. So this temperature is noted down. So this is called the cloud point, and when you are pouring this and pouring the fuel, then this is the temperature at which the just oil will cause to flow. So this will called the pour point temperature. So you can read this definition again. The cloud point of a diesel fuel is temperature at which the amount of precipitated wax crystal becomes large enough to make the fuel appear cloudy or hazy. Because of that, the fuel appears cloudy or hazy. So this is the apparatus that is called as a pour point or cloud point apparatus. So outside of this apparatus we will fill it with ice, and in between there is a glass tube. We will fill it with the fuel, and we will wait till the temperature reduces and fuel starts showing the cloudy nature or hazy nature. This temperature is noted down using the thermometer. Here you will place the thermometer to note down the temperature. So why the cloud point and pour point are important? It determines the temperature below which an oil cannot be used as a lubricant. So it determines the minimum temperature at which oil cannot flow. Both indicate suitably of lubricant in cold condition, thus must be low. So in cold condition what happens? Your lubricant oil get freezes. So it will determine that till what temperature you can take your vehicle outside. If the oil freeze and cloudy, it appears cloud, so you cannot start your vehicle. Your flow of the fuel will stop into the engine. And then another important point is lubricant can be used in a machine working at low temperature and should possess a low pour point. Otherwise solidification of lubricant will cause jamming of machine. So you should be your pour point should be low, so that it should not easily jam your flow path. The presence of wax in the lubricant oil raises the pour point. So you have there should be less presence of the wax in the fuel, so that it should not raise the pour point. Otherwise there will be problem in the flow. And pour point of an oil can lowered by lowering the viscosity of oil, which is achieved by removing the viscous constituent of the oil. So this is the solution how we can improve the pour point. So pour point of an oil can be lowered by lowering the viscosity of the oil, which is achieved by removing the viscous constituent that is into the oil. And next important point is lubricating oil used in the capillary feed system should have low cloud point, otherwise impurity will clog the capillary. And the cloud point has inverse relation with the density as well as the viscosity of the fuel. So why wax is forming into the fuel? Because wax may form because normal paraffin occurs in the diesel fuel. As temperature of the fuel is lowered, the wax, these paraffins become less soluble in the fuel as precipitate out as a wax crystal. So this is because of the presence of the paraffin. Whenever you are reducing the temperature of your fuel, these paraffins are depositing as a crystal, wax crystal into the fuel. So you have to improve your cloud point and pour point into your fuel, and it has to be lowered, so that within very less temperature this can have a flowing property. Your flow should not stop. So next is freezing point. So what is freezing point? We will come to know. First, the definition, you see, it is the temperature at which the fuel oil freezes completely and cannot flow at all. So it is the lowest temperature at which the fluid will freeze and it will not be able to flow. So why it is important? It is important in case of aviation gasoline, because at high altitude where low temperature are encountered into the planes, so into that case this fuel will freeze. Once the fuel is freeze, it will not be flowing into the engines. So if the freezing point of the fuel tank is not sufficient low, then fuel supply from the fuel tank to engine may be impeded due to choking of the pipeline. And aviation gasoline should have freezing point below 60 degrees centigrade to avoid the troubles. So this is the importance of the freezing point. It should be lowest to lowest. Next, we have octane number. Octane number is the property of gasoline which is used in a spark ignition engine and expresses its knocking characteristics. So, octane number is the property of gasoline which is used in spark ignition engine and expressing its knocking characteristics. How you can find out? To determine the octane number of the fuel, it is burned in standard engine. For the purpose, the knocking is measured by knock meter. So this is compared with the standard knock meter reading of the fuel of different octane number to determine the octane number. Importance Importance is high octane number and knocking has inverse relation. Octane number of gasoline is improved by addition of tetraethyl lead, or octane number of hydrocarbon fuel increases in the order of normal paraffin aromatics. So when a gasoline engine is made to operate at high load or low speed, a sort of rattling noise may develop from combustion chamber resulting from unsteady and uncontrolled combustion. This noise is called the knocking. So higher the octane number, better is the fuel, as maximum permissible power increases with the octane number. Next we have viscosity. So viscosity, you know the definition is internal resistance between the layer of the oil. That is called the viscosity. So what is the importance of viscosity? It's a measure of fluid's resistance to flow, or viscosity determines the performance of lubricating oil during the operation. Or a low viscosity oil is thin and flow easily. So high viscosity oil is thick and flow slowly. Viscosity and temperature have inverse relation, and viscosity is usually expressed in centipoise or centistroke. So this is the apparatus that is used to measure the viscosity. Redwood viscometer. It is called the Redwood viscometer. Now first we have Redwood viscometer, Redwood 1 viscometer, we have Redwood 2 viscometer, and then we have Engler viscometer. In Redwood 1 viscometer, it is used for low viscous fluid, and Redwood 2 viscometer is used for highly viscous liquid, and Engler viscometer used for moderate viscous liquid. Now this is the formula to calculate the viscosity. You can see it is equals to A into T minus B by T, where A and B are constant and T is the time taken to drop the fluid droplet, or the petrochemical product, or you can say fuel, that is filled inside the cup in the testing machine. So this is the time taken to drop the fuel. So here you can see this table where we have described the T, A and B. T for Redwood 1, it should be in between 34 to 100. For Redwood 2, it should be greater than 100. The value of A and B is given. For Igler, there is no range. Next we have emulsification. So what is emulsification? You can see in definition, some oil mix intimately with water and mixes is called emulsion, which has tendency to collect the dirt particle and other foreign matters. So few oils or petrochemical products or fuels have some mixing property with the oil droplets. So they mix with the oil and make the emulsion, and this emulsion have the property to dissolve the foreign matters into this. So due to this, the fuel is not safe. So why it is important? The first is the emulsification tendency is undesirable in most application of the oil, and second, forming of emulsion in a circulation oil system is undesirable because sticky emulsion slugs with oil circulation, and good lubricating oil should not form emulsion under the lubrication condition. Even if it is form an emulsion, it should break off very rapidly. Now next is vapor pressure. So you can see the definition of vapor pressure: with decreased atmospheric pressure. When the atmospheric pressure is decreased at high altitude, the vapor comes out of the liquid fuel, causing vapor locking and difficulty in starting the spark ignition engine. So whenever there will be uh, less atmospheric pressure at higher altitude, so into that case there will be a vapor that is coming out of the fuel, that is causing the locking and difficulty in starting the spark ignition engine. If the vapor pressure of the fuel is too low, starting the engine and lubricating oil dilution becomes difficult. So the importance of vapor pressure is, if the vapor pressure is high, that means the flash point is low and resulting in danger of fire and explosion. And lubricants having high vapor pressure will be lost quickly, particularly in case of thin film boundary lubrication. And if the vapor pressure is high, then vapor occurs in the vapor tank and pipeline, causing the pumping difficulty. So now we will come to know about the acid value or acid number. So what is acid value? You can see the definition: the number of milligram of the KOH. KOH is potassium hydroxide. So the number of milligram of potassium hydroxide required to neutralize the free acid present in the 1 gram of an oil. So in 1 gram of oil, the number of how many milligrams of KOH is required to neutralize the free acid into the fuel, that is called the acid value or acid number. So to the importance of acid value is determined to determine the acidity of an oil. The oil is how much it is acidic, and acid value of petroleum product should be less than 0.1. It increases the acid number, indicates the oxidation of fuel, which leads to gum and sludge formation besides the corrosion. So there should be very less acid or no acid should be present into the fuel, because it will cause the corrosion inside the engine. Now another property of the fuel is, or petroleum product, is calorific value. The calorific value is, the gross calorific value of petroleum fuels are in a range of 10,000 to 11,300 kilocalorie per kg. The higher figure being for gasoline, lower for heavy fuels. So petroleum products are high in hydrogen content, 11.8 to 14.5%, and hence their net calorific value is less than the gross by 620 to 760 kilocalories. So the calorific value you can calculate by using this formula. This is called the Douglas formula for theoretical calculation of calorific value. You can see this formula where C, N, O and S represent the percentage of corresponding element of the fuel. So this was all the specifications and properties of the petroleum products. So for any question, you can write me in the comment box or you can send me message. Thank you.